physics. First of all, we are discussing about nucleons. Every atom contains a center, an extremely dense positive charge nucleus. So nucleus is positive charge having high density. The nucleus is made of proton and neutrons. Protons have a positive electric charge, whereas neutrons have negative electric charge. Alpha ray scattering experiment. The alpha ray scattering experiment done by Rutherford from angular distribution of scattered alpha particle. Rutherford conclude extents of positive charge core of atom, then called nucleus. The size of nucleus was much smaller than the size of atom. Composition of matter. All the matter is composed of a little three fundamental particles: electron, proton, and neutrons. The mass of electron is 9.11 into 10 to the power minus 31 kg, and the charge is minus 1.6 into 10 to the power minus 19 coulomb. The mass of proton is 1.673 into 10 to the power 20 minus 27 kg, and the charge is plus 1.6 into 10 to the power minus 19 coulomb. The mass of neutron is 1.675 into 10 to the power minus 31 kg, but its charge is 0. The mass of proton and neutron are close, but they are about 1840 times the mass of an electron. A convenient way of describe an element is by giving its mass number and its atomic number, along with the chemical symbol of that element. So we represent A as a mass number and Z for atomic number. Size and shape of nucleus with respect to atom. The nucleus is assumed to be spherical in shape. The actual shape is not known. Area of sphere means the area of atom is 4 pi r square and its volume is 4 by 3 pi r cube. Density is very high and is equal to mass upon volume is equal to 10 to the power minus 27 upon 10 to the power minus 15 to the power whole cube equal to 10 to the power 18 kg per meter cube. A study of nucleus was made by Rutherford and his thought scattered cross sector. The nucleus. The mass number is the total number of nucleons or number of the mass number is the total number of nucleons or the sum of number of protons and neutrons. The atomic number is the mass of a proton or mass of electron if atom is neutral. Neutron number. The radius of nucleus can be found by r equal to r naught a to the power 1 by 3, where a is the mass number and r naught is a constant and equal to 1.25 into 10 to the power minus 15 meter. Isotopes. The isotopes are the atoms that have the same number of protons but a different number of neutrons. Nuclides. Because of existence of so many isotopes, the term element is sometimes confusing. The term nuclides is better. The nuclide is the atom that has a definite mass number A and Z number. A list of nuclides will include isotopes. The following are the best described as nuclides. Helium and helium. Helium of mass 3 and helium of mass 4 are the nuclides. Nucleides. Atom या nuclear with specific N and Z called nucleides. Isobar. Two atoms with same mass number but different atomic number called isobar. Isotones. Nucleides with same N. Isomers. Same nucleides but different energy state called as isomers. Now we are defining a term called atomic mass unit U. One atomic mass unit is equal to 1 by 12th of the mass of most abundant form of the carbon C12 atom. So atomic mass unit 1U equal to 1.6606 into 10 to the power minus 27 kg. Common atomic masses are mass of proton is 1.007276 AMU, mass of neutron is 1.008665 AMU, the mass of electron is 0.00055 AMU, and the mass of hydrogen is 1.007825 AMU. Mass and energy. Einstein gave a relationship between mass and energy as E is equal to mc squared, where m is the mass of atom and c is the speed of light and E is the energy. So the energy of mass of 1U can be found equal to 1U into c squared. 1U is equal to 1.66 into 10 to the power minus 27 kg, and C is the 3.3 into 10 to the power 8. So we found E is equal to 1.49 into 10 to the power minus 10 joule for 1 AMU mass. Or E we can write 1.49 into 10 to the power minus 10 joule of energy as a 931.5 mega electron volt. This is a simple problem about Einstein formula. What is the rest mass of a proton? We apply the formula A is equal to mc square and we can find the rest mass of proton. The mass defect. The mass defect is the difference between the rest mass of nucleus and the sum of the rest mass of constituent nucleons. During the combination of nucleons, some of the mass is converted into energy. So mass of atom got nucleons got decreases. This difference of initial mass and the final mass is called as mass defect. This is an example about mass defect. The average atomic mass of boron is given. What is the mass of nucleon of one boron atom in kg? This is a formula based question, simple problem. The binding energy. The binding energy of a nucleus is the energy required to separate a nucleus into a constituent part. Actually, in atom, nucleons are binded together with a force called nuclear force. To separate those nucleons, we require energy. This energy is called binding energy. Binding energy represents the stability of nucleons. More the binding energy, atom is more stable. So binding energy is written as mdc square, where is the mass md is the mass defect, means the difference of initial mass and final m. So eb is also written as del mc square. The binding energy per nucleon. An important way of comparing the nucleus of an atom is find their binding energy per nucleon. The binding energy per nucleon is equal to binding energy upon total nucleons. Formula for mass defect. The following formula is used for mass defect are Z into mH plus N into Mn minus M. Binding energy. We can write the binding energy as a del mc square is equal to Mn minus Z times Mp minus A minus Z whole bracket Mn into C square. The binding energy versus mass number. Given curve show that Eb increases with as mass number increases, binding energy is increases up to m mass number at 50 plus, just 50 more. But after mass number 60, the binding energy is decreases. So we can say that the most stable nucleus is in the range of 50 to 60. So iron is the most stable nucleus. Through this graph we also conclude that smaller nucleus try to do fusion. Through fusion they bind together and make a big nucleus to make more stable. But in other hand, bigger nucleus try to do fission breaking so that it make itself smaller for more stability. Binding energy per nucleons. Nuclei with the largest binding energy per nucleon are more stable. The largest binding energy per nucleon is 8.7 mega electron volt for mass number A equal to 56. Beyond bismuth, A mass number 209 nucleus are unstable. Stability curve. Nuclear particles are held together by nuclear strong force. The stable nucleus remain forever, but also ratio of N by Z get large. The atom decays. Elements with Z is greater than 82 are all unstable. The strong nuclear force hold all the nuclei together. Otherwise, protons will repel each other because protons are positive charge. So repulsion causes due to electrostatic repulsion force. Neutrons space out protons and makes nucleus stable. Nucleus are stable because of their nuclear force. This nuclear force are apply in very short range of distance and does not depend on charge. Note, all isotopes are radioactive. Only unstable nuclei decay. In small atoms, stable isotopes have an equal number of protons and neutrons. In large atoms, stable isotopes will have more neutrons than protons. Too many or too few neutrons make the nucleus unstable. The modes of radioactive decay and the type of radiation. To understand mode of radioactive disintegration and type of radiation, to learn about basic atomic structure alpha, beta and gamma decay, positron emission, difference between gamma ray and X rays, orbital electron capture and internal conversion. Isotopes. The number of protons determines the element with the same number of protons but different number of neutrons are called isotopes. Some isotopes are radioactive. Radioactive decay. Spontaneous change in nucleus of an unstable atom result in formation of new atoms accompanied by release of energy either particular or electromagnetic or both. Nuclear instability is released to whether the neutrons to proton ratio is too high or too low. Radioactive decay. Radioactive decay results in the emission of either an alpha particle, a beta particle, a positron, or a gamma particle. One point is here noted that the mass atomic number must be same in both sides of equation. Means the mass and atomic number are not destroyed in nuclear reaction. Line of stability. The given upper line is a line of stability. Those atoms which are in this are fall in this line are more stable. Alpha decay. We are dealing with alpha decay. Alpha particle is identical to that of helium nucleus. Alpha particle means helium nucleus with charge 2 and mass 4. So unstable atom decay with its daughter nuclei and alpha particle. Uh, Here is the example of radium. Radium decay into radon and helium nucleus. Radium lost 2 proton and 2 neutrons. Alpha emission. Emission of a high energy helium nucleus from a nucleus of radioactive atom result in decay product whose atomic number is less than the parent and whose atomic mass is less than the parent. Alpha particles are monoenergetic. Alpha particle decay. Decay by alpha emission. Beta emission. A beta particle is a fast moving electron which is emitted from a nucleus of an atom undergoing radioactive decay. For example, nucleus X is decay into, it is a knowing fact how nucleus have no negative charge, but how nucleus produce negative particle, beta particle. Actually here one proton is breaked into neutron and electron. No, one neutron is breaked into proton and electron. Those breaked proton goes into daughter nuclei Y and electron is released. So X is breaked into Y and electron. The atomic number of Z becomes Z plus 1, but mass number does not change. Positron emissions. The positron is a beta particle having charge of plus 1. This phenomenon is occur when neutrons to proton ratio is very low. This is a related problem about positron emission. What is electron capture? The electron capture is opposite to beta emission. The capture of electron allows a proton to turn into a neutron. This is a simple problem related to electron capture. You can go through it. Orbital electron capture. The orbital electron capture is also called as K capture These occur when neutron to proton ratio is too low. Form of decay competing with a positron emission. One of the orbital electron is captured by the nucleus, result in emission of characteristic X-ray. Gamma decay. When atom decay by emitting alpha or beta particle to form a new atom, the nuclei of the new atom formed may still have too much energy to be completely stable. This atom will emit gamma ray to release energy. Gamma ray are all high energy radiation. Gamma ray are not charged particle like alpha beta particle. So through this paragraph we conclude that gamma ray is released to stabilize the daughter nuclei. Internal conversion, the alternative process by which excited nucleus of gamma emission isotopes rids itself of excitation energy. The nucleus which interact with orbital electron ejecting the nucleon from the atom. A characteristic X-ray are emitted as outer orbital electron fill the vacancies left by conversion electron. These characteristic X-ray can themselves be absorbed by orbital electron ejecting them. These ejected electrons are called auger electron and have a very little kinetic energy. This is a one-page summary of radioactive decay. Please summarize this. These are the problem. In a research laboratory, electrons are accelerated to speed 6 into 10 to the power 6 meter per second. Nearby at 1 into 10 to the power minus 19 kg speed of dust fall through the air at a speed of 0.02 meter per second. Calculate the de Broglie wavelength in both cases. In first case, we can write lambda equal to h by p, where p is the momentum is equal to mass into velocity, and we can put the numerical value of h, m and v. So we find lambda is equal to 1.2 into 10 to the power minus 10 meter. In dust case, lambda of dust is equal to h by p is equal to h by mv, and on putting the numerical value we can find the lambda d is equal to 3.3 into 10 to the power minus 23 meter. This is a second problem. The electron microscope use 40 kilovolt of electron. Find the wavelength of the electron. We can write velocity is equal to 2 km by. This formula comes from kinetic energy is equal to half mv squared. So v is equal to root under 2k by m. On putting the numerical value, v comes to 1.2 into 10 to the power 8 meter per second. The wavelength of the electron lambda is equal to h upon mv. So on putting the value, lambda comes to 6.1 into 10 to the power minus 10 meter, or 6.1 into 6.1 angstrom. So these are the all about nuclear physics.